Video stream. What do I do?
Video stream. If you want to, yeah, you have to.
Yeah. How do I plug into share the slides on this?
You have to join the meeting.
I have joined the meeting.
Recognize the chair.
I am recognized as a chair. I am not sharing anything. That's why. What I have to do is to do the sync slides thing. Always remember to do the sync slides button. Reload meeting material. We're already late, but a few people are arriving. Hey, how are you, mate? Not too bad. Share preloaded slides. Sorry? Ed isn't coming. Ed tested positive last week, so he's hoping to drive down on Thursday if he's testing negative. He's here already. Good morning, everyone. Is this microphone working? Can anyone hear me on the internet as well as in the room?
Good morning, Rick.
Yes, I'll take that as a send. Good morning, Ed. How are you today?
Better.
Good. So just as a little bit of background, Ed was hoping to be here in person, but due to the vagaries of COVID, he will be remote, which is unfortunate for some of us who wanted to say hello to him, but it sounds like you're better. Well, definitely on the mend by the sound of it. So we don't have a great number of people in the room, but we have a fair amount of people online, which is great. Am I close enough to the microphone? Just an audio. I'm going to handheld and pretend this is some kind of like community disco wedding thing. Okay. I'm not. I promise not to sing. So I think we should start because we're a little bit late already. We've got a few people in the room, but we've got quite a few people dialed in, which is great to see. Just as, can I make these slides move through? There we go. So I will start the session by just talking about the note well, and Ed, please just jump in, unmute your mic and shout when you need to. A note well, I'm assuming many of you have already attended an IETF meeting before and familiar with the note well. If you have not, I recommend you take your time to read this carefully. This is also available online for your reference, but the long and short of it is anything you say at the microphone or within the chat is a disclosure. So be very careful about any IPR you wish to discuss because you are disclosing it and making it public as you do so. The fine details, I am not a lawyer, are carried in the various BCPs. I recommend, if you are uncertain, to read this carefully and ensure that you're not going to make some terrible mistake and get in trouble with your sponsor's lawyers. Moving on. Meeting tips. So most of you have already managed to dial in remotely, which is great to see. I don't know how you get to see this if you are struggling to get in, but they are available through the data tracker. So I'm assuming those people who are struggling to get in can find the information on how to get in. In-person participants, can we request that you use the in-person tool? It's great on a phone. There are QR codes liberally scattered around the room. If you scan that, it will take you straight to the relevant meeting. In-person tool, which allows you to put your hand up and join the queue, and therefore we have one queue synchronized between remote participants and in-person participants, which is great. Also, try and mute your microphone. Let's sort of try and avoid the embarrassing feedback and all that kind of stuff you get with remote participation. But after 2.5 years of COVID, I think we're all pretty savvy with dialing into meetings. Next up, for those of you who can only access the slides and can't hear me, there's not much point me saying this, but the agenda is visible through the data tracker. That's the URL for it. Important information on how to join the Meet Echo. Seems a little bit ironic to show it through Meet Echo, but it's there. And most importantly, if you are struggling with Meet Echo, there is the URL for how to get fixes for it. Hot tip, put some emergency message, including the word Meet Echo, into the chat, and they are pretty quick at responding to you through the chat if you are struggling with video or audio. So moving on, our agenda. We originally asked for 2 sessions, 1 hour and followed by a 2-hour session, because in discussion between Ed and myself and various others, it was felt that it would be productive to have a more of a working meeting to talk around the very broad topics of naming and addressing. I think between many of the participants in the working group, we're starting to condense around some basic ideas around naming and addressing. We don't have any drafts in progress on this. It would be great to get some drafts here, but before somebody really puts their neck out and starts writing an extensive draft, I think there's some general nervousness about understanding the full scope and where everyone else is thinking. So the idea originally was we'd have a 1-hour session just to talk through the status of the documents we've got, and then a 2-hour workshop. Unfortunately, we were unable to get both sessions, so we are compressing it into 1 session today. So the idea is we will go through the various documents and some questions to the working group from the likes of Keith Scott and CCSDS, and Scott Burley will also be talking through his thoughts about naming and addressing and what he's collated from his conversations with interested parties, and that should kick into the naming and addressing workshop, which we will reserve the 2nd hour of the session for, minus 5 minutes of open mic at the end. So what's next? Okay, so we always need a minute taker. Adam's put his hand up already for those who can't see. But it is a shared note-taking system. It's integrated into Meet Echo. It's pretty good. Please don't just rely on Adam to do all the typing, because that's a bit unfair. And most importantly, when you state your name at the microphone, if Adam has missed it and misspelt your name or has misquoted you, just double check that he's got that right, because people talk fast and people get excited, hopefully. Other reference, mailing lists. You should be subscribed to the GTM mailing list if you want to hear the meeting conversations that are happening. And if you need to contact the chairs, we have an @IETF email address, which will contact both Ed and myself. I will pause here to say, Ed, is there anything else you want to add? Because I am just talking at the moment.
No, so I can, I just want to make sure you can hear me okay. My mic volume is all right.
Yep, all good.
No, I think that's a good intro. I'm sorry I couldn't be there in person. And I just wanted to take a moment and talk a little bit about the CCSDS and the SIS-DTN working group. And maybe we can use that as a roll into our first set of presentations and discussion topics. So for those in the IETF who are unaware, the CCSDS is the Consultative Committee for Space Data Systems. And it is a standards organization, a peer standards organization that builds standards for space. And in that organization, there is also a DTN working group chaired by Keith Scott, who is here today. One of the topics of conversation and areas of overlap in these 2 working groups is how much of the DTN ecosystem and the DTN architecture is shared across space and terrestrial use cases, and what pieces of this are specific to space constellations, deep space and near space exploration versus those that are more general purpose. And as you can imagine, when we start talking about in pieces, naming and addressing, quality of service, resiliency, custody transfer, and so on, there are questions relating to are there niche cases for space that require their own solutions or their general solutions across? To that end, there is discussion about how much of the standards are done 100% in the IETF as RFCs versus what pieces are done in the CCSDS as books. So sorry for that reprimer. Maybe that's already known, but maybe not everyone online is familiar with the CCSDS. But to that end, CCSDS asked if they could come to this meeting and spend 10 or 15 minutes and talk through some of the areas that they believe exist in an overlap, and to understand from a working group perspective here in the IETF whether we agree or disagree with some of that. So with that as introduction, I would invite Keith Scott to join in, and we can start sharing his presentation slides and start his set of discussions.
Awesome. Can somebody there push the slide?
Yes, give me 30 seconds to just queue up the next set of slides through Meet Echo. It's normally
All
very
right.
good. It always takes me a moment to find the right slides.
Cool. So while you're doing that, some sort of status. I'm Keith Scott. I chair the CCSDS SIS DTN working group. As Ed pointed out, CCSDS is the standards body that is responsible for setting standards for civilian space missions and interoperability among sort of a suite of space agencies, both national and multinational. There, we of course are very interested in bundle protocol, and just finished submitting a CCSDS profile of BPv7 to to Tommaso DiCola, who is the Space Internetworking Systems Area Director in CCSDS for standardization. The protocol profile there really is very much grounded in the BPv7 RFC. So the profile within CCSDS says, you should implement RFC 9171, and then here's some clarifications there. A couple of restrictions. For instance, we wanted to say that a compliant CCSDS implementation didn't necessarily need to deal with bundles larger than, I think we picked like 10 meg as a size, just to give missions sort of an out when they're doing implementations, that they don't have to deal with things that are too large for them to handle. And then CCSDS always wants like a service specification, so there's a service specification in the CCSDS document. In addition to that, we defined a couple of convergence layer adapters that are useful for space missions. So in particular, an LTP convergence layer adapter, where one of the things that we did there was allowed, essentially used a type link, a type value pair or length value pair to allow multiplexing of multiple bundles into a single LTP block. And that, of course, imposes a requirement on the receiver that they're able to parse those out. But essentially a CBOR unsigned integer followed by a bundle, CBOR unsigned integer followed by a bundle to make things work out there. One other thing that is sort of a working point between, I think, between CCSDS and the IETF is not just sort of where the points of overlap are, but the timing of various needs. CCSDS has got a couple of missions now that are using BP. They're moving out. I think PACE is still looking at a version that is based on BPv6, and they did that partially because they're interested in the BPv6 custody, transfer, and reliability mechanism, which is one of the things I'd like to talk about. But in general, there may be things that are where there may be times where the sort of the needs timelines of CCSDS and IETF diverge, and Ed and I talk regularly So we sort of understand where the two efforts are going, but there's a strong desire from our part, and I think from Ed's as well, to keep the two efforts in line as much as makes sense. So if there are certain things that we need to do from a CCSDS standpoint, if we can define a common mechanism that can be used by sort of the larger community within the IETF as well as CCSDS, I think that's better, and will be better for CCSDS in the long run, because their end goal really is to deploy bundle protocol as the networking layer for space communications, and then hopefully someday to go off and buy commercial products for the ground that deal with that on the ground side. And then the various space agencies will always have to write their own flight implementations, because flight software is, as Ed can tell you, its own thing. So there are a couple of areas where, as I said, we've just gotten through dealing with this profile of BPv7. As as you did, we pushed a lot of things off to later in order to get an initial specification out the door. So things like reliability, how to do accounting, what we're going to do with quality of service, all of those things we did not try to add on and tackle those in addition to 9171. But the time will come soon, and sort of is now, where we need to turn to those things, because those are the next set of things that we need as well as you. So I think that in the IETF DTN charter, I think that reliability, certainly reliability, quality of service, network management are all in your charter, and I sort of wonder if network management might also include accounting. There's so maybe I'll just go through this. I think if I hit the next slide. So reliability, sort of at the bundle level, not necessarily a series of reliable convergence layers. Some of the goals especially for some of these space missions, is absolutely to be able to release resources as soon as possible. And while a series of reliable convergence layers is a good way to get reliability, there is a desire for something that is a little bit stronger than that is actually signaled at the bundle layer, for dealing with cases where we may have a link where you just can't get a reliable convergence layer. If you've got a unidirectional link, and there's some multiple access mechanisms with TDRS, where you've got unidirectional links, you may end up having what are essentially unidirectional links from various space missions, just because of the delays and your inability to actually turn a signal around and get it back out in time to sort of close a link before you want that ground station back, and you need the antenna resource on Earth to go do something else. So the BIBE custody transfer, or the BIBE draft with custody transfer, is a way of providing that, providing the reliability mechanism. It's signaled. There's ESA has, the European Space Agency has expressed a desire for a capability that is more akin to the way things were done in BPv6, where the bundle sort of carried with it natively a request for a reliability mechanism. ESA also has some thoughts that sort of blend reliability and this accounting notion together into ways that they might be able to do more bit efficient, essentially something that is akin to the aggregate custody signaling mechanism that was implemented in ION and used for the International Space Station, developed for ISS. ESA is interested in using something like that, but expanded for maybe to support things other than just reliability and custody transfer, but also some of these accounting mechanisms. So ways that you can send signals, metadata about bundles and the state of the network that are particularly bit efficient there. Let's see, yeah, next one. So that accounting is really sort of where really where are the bundles and where are the resources and how are they being used. We put together these slides within the working group. Yeah, Ed?
Sorry, I just before we went through these, I had a quick question, which is, how do you want to handle questions? Do we want to go through all of these and then have questions at the end, or do we want to talk reliability, questions about it first, and go on to the next?
We can do questions on reliability now. That worked. Do people have such questions?
Well, so my question, so there's at least one question, because I have a question, is when we talk about reliability, when we talk about this kind of custody signaling, then it seems that there are two proposals out here for custody signaling, right? One is there a custody signaling mechanism that could be put into an extension block? The other is custody an artifact of an underlying convergence layer like a BIBI convergence layer? My question for the working group is, do we believe that those are two options that exist in parallel, or do we think that there would be one or the other? Are there any thoughts on that?
So my thought is you always have the option of reliable convergence layers. So it almost can't be one or the other, because you're always going to have the question is really, do you think that you're going to architect your network in such a way that you always know that you're going to have that series of reliable convergence layers? Well, maybe two questions. First is, do you need reliability do you want reliability of the network from bundle protocol to be a service that's provided? And if so, do you think that you will always be able to architect your network in such a way that you have reliable convergence layers along the entire path? Over.
So can I just jump in a second? I joined the queue. From my perspective, even if you have reliable convergence layers across the entire end-to-end path, I still think there has to be some signaling somehow at the bundle protocol level to say, I need you to use those reliable convergence layers in case an individual BPA has a choice between a reliable and an unreliable convergence layer at a certain hop along that path as the bundle transits. So I think it has to be explicit in some way, either through BIBI or through having some signaling, conceivably both if there is interest in doing both. But I think it has to be explicit. It can't just be implied that, oh, I have built my network entirely out of reliable convergence layers, therefore everything will be reliable, because not all traffic needs to be reliable. So I think that you will solve one specific use case, but at the IETF, I think we need to consider slightly more generic solutions for some of these things.
I think Jonathan's up next.
Yeah, go on, Jonathan.
Yeah, I just wanted to add a little bit more to that. And when we talk about the custody signaling at the bundle level, we're saying things like we've actually had the space of this resource to store it, and that the bundle is completely parsed and there are no errors, and it's acceptable. You can't get either of those kinds of things with a reliable convergence layer. The convergence layer just says, I got a bunch of bits, and they're the bits that were sent, but it doesn't tell you that I was able to actually store that bundle, or the bundle parsed completely without errors or exceptions of any type. So that's the kind of thing in the space community we're looking for, that the data is completely intact, not being able to store it. And so the previous node can now release it. Say that node is a small rover that wants to get its data reliably back. And once that is the resource is freed on the rover, it can go about doing its normal thing, capturing more science data or doing whatever. So that's one of the underlying rationales where we're really interested in getting reliability at the bundle level. And I agree with Keith in that all these are options. Bundle level reliability, convergence layer reliability are things that we should allow in the protocol.
Go ahead, Scott. Just for notice, I locked the queue here because I'm trying to keep. This is a really useful discussion about reliability, but I don't want to eat the entire session about reliability. Yep. And with my chair hat on, I think much like we're going to tackle naming and addressing in a slightly workshoppy manner here, I think I'm hearing a lot of opportunity for good discussion about what do we mean by reliability. So I know people have got valid points, but let's just cut the queue at this point. Carry on, Scott, and Brian just jump in.
Right, just very briefly to go to your point. Can you hear me?
Yep.
Yes, loud and clear.
Okay, good. The signaling of what sort of convergence layer protocol the source application desires to be used end-to-end is one of the things that I think we ought to consider in quality of service when we get to the quality of service conversation. I think that signaling is a useful thing. Quality of service is something that we need to spend some time on anyway. And I agree that both reliable convergence layers and reliability within some sort of reliability mechanism within bundle protocol using some sort of an extension block are worthwhile things to discuss. And that's all I've got for now.
Thanks, Scott. Go ahead, Brian.
Cephas. I just want to help frame the discussion on this last point about the convergence layer cannot provide this. Right now, at least the reliable convergence layers, the TCP/CL and the LTP/CL, they could do this, but they both are silent about what the acknowledgement currently means. So either a CCSDS profile of these convergence layers can say that if you acknowledge a transfer, it means it's gone all the way into the forwarding queue or storage or whatever that is, or an individual network operator could enforce that. So it is possible for that to have meaning. It just isn't specified right now.
Thanks, Brian. Go ahead, Ed.
Yeah, thanks. So Rick, I was also about to try and say, let's not have this whole conversation here in real time. But I was going to say, it seems like there may be some energy towards perhaps an extension block or other mechanism to signal reliability and custody. So if please keep that in the back of your mind as to whether that's work that the IETF should be handling, CCSDS should be handling. And then also, as we identify custodians, that's going to take us back into some of the naming and addressing conversation later in this meeting. So please remember that as a use case.
Brilliant. Good summary. Okay, carry on, Scott. Oh, sorry, Keith.
Yep. Okay, accounting. So the accounting is a big deal in these space missions. They very much want to know where all of their resources are being used. If there's a question about where that data actually is sitting right now, they are for these space missions, the difference between, or a difference between them and the IETF, this is really their first foray into networking. Space missions currently are very much run as I've got a mission operations center, I have a link, I have a spacecraft. There's one spacecraft. It is the thing that I talk to. So they're quite concerned about understanding did this bundle make it to the ground station? Did it get radiated? Did various things happen with it? So some of these questions are accounting questions, sort of along the lines of what might be internet or telephony even accounting, right? Where are my resources being used? Where's my data? Some of the stuff that's on this slide that's in accounting, is really seems to be more is more, I think, network management. So how much storage is there at a node? I think here, there are sort of a couple of things going on. One is this desire to be able to get insight into where bundles are, have they made it past this node, what's going on there, which will become more and more important as we get into sort of multinational cooperative networks, right? Think of we're going to have things that are like autonomous systems, where there are some nodes in this network that are run by NASA and some that are run by ESA. And as we all know, whenever anything goes wrong, the first thing people do is point at the network and say, "Oh, your network isn't working right." And so having the accounting mechanisms to be able to say where things are is going to be important there. One question that I have is whether or not, so that's one bit. The other sort of more network management, more directly network management bit is state of nodes, where you may be asking things like, how much storage does this node have? How many errored bundles did it receive? And things like that. I think that a lot of those are probably addressable through something like AMP and having the right information in some ADMs that we can ask for. A big question that I have is whether or not the sort of the first of those, the sort of real-time accounting needs, things that you might get from the bundle status reports, right? So we have this bundle status report mechanism. The part of the reason that we don't really want to use that operationally is it introduces the potential for there to be a lot of overhead in the network, and you might need to carefully craft rules saying who is going to send various status reports when. And even if you do that, if you're traversing a chunk of like the terrestrial internet, then where you're not in control of those bundle nodes, then you don't get to say whether or not they will actually generate the status reports. And the fear there is maybe not so much that they won't generate them, but that they will, and that those status reports then go back to some space asset, and chew up a lot of very expensive and scarce resources on the way there. So a question that I have is, if you look at this slightly differently, I wonder if AMP and the network management capabilities might be configurable in such a way that we could use them to generate some sort of network management, if we define the ADM the right way, some sort of network management message for, I saw a bundle that looked like this that went through me.
So I'm going to jump straight in to answer that, and then I'm going to let Ed probably answer it much better than me. From my perspective, status reports really are control plane inbound signaling, really to try and keep the bundle forwarding process working correctly. What you're talking about here is very much statistics about the smooth operation of your part of the network as a whole, which is a very valid request and needs to exist. It just needs to exist. It's sensible. So I would suggest that the DTN management stack would absolutely be able to collect and aggregate these statistics and generate them as reports using what was called AMA, AMP, etc. there has to be a clear separation between, we don't just use status reports and use that as the signaling mechanism. It's got to be done through that common management infrastructure, which tackles the issues around not having that end-to-end connectivity at all times, flooding out of traffic, intentional transmission of when that data is important. But I'll let Ed explain that in much more detail.
Well, so exactly right. And what I just wanted to say here is we did have some of the DTN network management stuff on charter for this meeting, but given that we were 2 hours and not 3 hours, we wanted to make sure that naming and addressing went first. Generally, in IETF and CCSDS, there is an understanding that some level of local autonomy is needed in the management plane to do exactly the kind of things, Keith, that you're talking about, which is to make decisions about, well, ultimately to make decisions about self-configuration, but also to understand when you need to do reporting, particularly if you are starting to queue and store and forward reports for others while you don't have connectivity. The area where this may be overlapping with IETF and CCSDS, or that's the overlap, the area where there might not be overlapping with the IETF and CCSDS are questions about the on-the-wire encoding of this kind of autonomy model. And so there are questions that we are addressing in the DTNMA document, the informational RFC around this, related to whether, in the IETF, do we use something like COAP for the encoding of these messages, and do we use sort of a different encoding for areas that don't want to be or can't be running COAP? And I think that's going to be sort of the hot topic at the next working group meeting and the mailing list to kind of catch up to it. But I think the autonomy model, the data models associated with it, and the use cases for what we want to do for this kind of accounting and intelligent local accounting are going to be shared across. So hopefully that's just a little bit of a preview.
Awesome.
Sorry, Keith. I'll add one last point. I can see an ops AD in the room. So there is a liaison between this working group and the larger network management area within the IETF to make sure that we are fitting in with best practice from the IETF based on many years of running, managing, and monitoring networks. So we have access to that wider depth of knowledge within the industry so that we can bring across best practice and align what we're trying to do with, and trying to avoid the mistakes that other people have made in other areas, and not just invent our own processes that miss out some of the subtleties. So we have I think that's the one advantage of the IETF, is that we have access to this depth of knowledge in a broader area. So I'm kind of looking at the AD at the moment saying, this is where we will liaise with you guys to make sure, to double check our homework.
Yeah, so Robertson, Cisco, Ops AD. So yes, that's helpful, and I think that's the right sort of attitude to have and direction. So I think we can certainly try and get the sort of cross-pollination reviews and ideas and things as necessary, and make sure that everything's sort of working together as possible and reusing bits that we can. I know there's some different requirements here in terms of handling things. Things don't just work the same way, but there are certainly be areas of that which we probably can leverage and use sensibly.
Brilliant, thank you. Carry on, Keith. Cool.
Awesome. That is the bulk of what I think we really need to talk about right now. There's a couple other things that were on that first slide relating to QoS and priority, which we're going to talk about later. The only other item that was there was one thing that we did within CCSDS, and sort of as a measure of expediency when we did the BPv7 profile. We also defined a separate UDP CL, which is different from the one that's in RFC 7122. Essentially, just the dirt simplest UDP CL that one could come up with. There's no notion of keep alives. It's just one bundle, one UDP. I think that for the cases that we need, that will serve us really. If there's if there's some need to incorporate that into some other document, then obviously it is so simple that it hardly bears mention in that case. But that does exist in the context of CCSDS for anybody who is interested in it.
So Keith, on
And
that point, I'll just jump in again. Sorry.
Yep.
I know Brian Cepos is looking at updating the UDPCL as a BIS document. I'm interested if he wants to let us know how he's getting on with that, but it's not critical. But if CCSDS has a specific use case for a very ultra lightweight CL that they want to quickly knock up, specify, and standardize, that's absolutely fine. It's the nice thing about having this kind of and it isn't a formalized API, but that kind of separation of responsibility between the bundle processing and the how do I move these bundles between point A and point B at the equivalent of the link there. There's no problem. If you want to liaise and unify onto what we're working on and give us input, that's also fine. So I don't see this as a contentious point.
Awesome. I'll get with Brian and figure out what he's doing there.
So we've got Eric in the queue. Sorry, Keith, let me hold on.
Sorry.
Sorry, Eric Klein, Illyria. I wanted to ask the CCSDS UDPCL, how does it handle MTU issues? Or are you assuming that you can always put a 10 meg UDP packet? A 10 meg bundle
we assert that you've got to fragment the bundle in order to fit it into UDP datagrams.
Fragmented at the IP layer then?
Fragmented at the bundle layer.
At the bundle layer.
At BP.
Okay. Yeah.
So essentially, we've got an MTU like notion for the CLAs, or at least for the UDP CLA.
And the MTU is known administratively.
Yeah.
Okay. Thank you.
For those links. Hey, I'd like to thank you guys. I realize that I've gone way over time. This has been a really useful discussion, I think, for us. And my plan is going to be to just work with you and in particular maybe through Ed, who also participates in the CCSDS area stuff, and make sure that we move forward in a way that makes sense to everybody. Over.
Thank you very much, Keith. I think that was really useful. I know we have a kind of unofficial liaison with you through Ed and various people who participate in both events. I think keeping this communication open between us and honest between us, I think is good for all of us involved. So thank you very much for speaking today, and let's keep working together and making it all just better. Okay?
Yep. Yeah, agreed. Thank you, Keith.
Great. So I'm happily sharing slides, which means I can't see who's up next. Has somebody got access to Ed? What's next on the agenda? Because
certainly. So next on the agenda we have Brian Cepos, and even though it's listed as 2 agenda topics, there's a single consolidated slide deck to talk about 3 things: administrative records, the COSI BPSec security context, and then some thoughts on neighbor messaging, which will then lead us into Scott, which will then lead us into naming and addressing.
Perfect. Thank you, Ed. Go ahead, Brian.
All right, thanks. All of these topics are going to be pretty short. I want to skip through them and really get feedback. That's the goal for presenting this. So the first topic, and all of these things have roughly been presented previously. So what I'm trying to do is get a little bit of more conclusion on some of these. So on the topic of the administrative record types, this is roughly the same information that was presented at the last IETF. And the idea is that there was a little bit of a gap left from RFC 9171 that there's an IANA table of administrative record types. It was not updated for BPv7. And the point of this draft is to make those updates so that it's consistent with BPv6 and V7. And there was another comment to explicitly say that there's no change to the registration procedure, which is a reasonable thing to state. It's not a change, so it's just making sure that the reader is aware that there is no change. And what it looks like, it boils down to this updated set of IANA tables. And the kind of feedback that's wanted is, first, it would be good to get this adopted. So this is a request for a call for adoption, and also a request for, assuming it is adopted, that there's more comments on the document, like, should this be 2 tables, should this be 1 table, more editorial things. The contents of this are what's already in existence. This is not a proposed change to any behavior. This is just reconciling the IANA tables with reality, including the aggregate custody signal allocation that was made by CCSDS but never actually rolled back into the IANA table. So just making sure that whoever reads the table understands what the real situation is.
Thanks, Brian. I'll take an action here. So this is Rick. I'll take an action here to put a working group adoption call onto the list after this session. It may not be this
Okay.
week. And we'll just get it in, get some review on it, and get it through, because by the sound of it, it's not contentious. So I'm hoping we can move fast on this. Thank you.
And it is necessary for future changes, like adding new administrative types. It'll be necessary eventually. And for example, reserving the experimental range just isn't there right now. Like, for example, the ACME document and the BIBE document would need code points. Next topic, again, hopefully short, the COSE context. So this was presented at an earlier IETF as well. And the idea here is that the existing RFCs define a default security context that is very focused on symmetric keyed algorithms. It does exactly what it needs to do in a narrow scope, but it doesn't handle any notion of asymmetric keyed algorithms, or more broadly, any PKI integrated security. This was something that was brought up by the IETF sector in the BPSec review, and it was also something that was presupposed by existing NASA and IOAG future architectures, that PKI is what's going to be used for integrating disparate networks. And right now there isn't a mechanism to do that. So this proposal is saying we want to use this pre-existing structure and algorithmic processing, which is CBOR object signing and encryption, COSE, and put it into BPSec. And the idea here is then that we're going to embed COSE as a BPSec security context. It occupies 1 code point because different COSE messages have different code points that they self-distinguish. They can be used for signing, they can be used for encrypting, and there's some additional technical details in here for deduplication to avoid having a lot of duplicate data within the security context data. And COSE itself is a roughly compressed storage of the security data. And then part of that is to propose for this interoperability security profile that includes symmetric keyed algorithms, and then on top of that, asymmetric and also PKI facing algorithms. So the end goal of this is that you can just use existing BPSec fundamental structure within a PKI and with existing tools that handle COSE.
So Brian, Rick again, just a quick clarifying question. So do you have a draft for this? And is it, because I've just had a quick look at the data tracker documents, has it expired, or you haven't put it through to DTN? Has it gone to COSE?
It's expired, yeah.
Right. Okay. So your intention is to send out a new update to reinvigorate it and ask for working group adoption. Is that the plan?
Basically, yes. Yeah, that if there's any comments against the existing behavior, I'd like to get some feedback, but also know that it's feedback that would be directed towards a working group document.
Okay, to that end, given it's expired, and you don't, from what I can hear, you don't have any edits in order to put out a new version. Can you send a link to where it lives, because it's difficult to find it through the data tracker as a casual
Sure.
working group attendee? So just to say, it's here, please can I have some review, and we'll try and reinvigorate it and get it adopted from that point or whatever. Okay.
Okay. And there are potential minor edits, like the RFC 9173 changed its definition of AAD, and the idea is this would be updated to be consistent with that. We want to make as few amount of changes as possible.
Well, that might be a really convenient way to reinvigorate it, is if you want to change one or two small things, push out a new version, it'll become live back in the data tracker, easier for people to find, and we can do the working group adoption call at that point. Go ahead, Ed.
Okay.
So a few things. One, without my chair hat on, I just wanted to say that I'm personally supportive of the work, and I think that getting some additional BPSec security context defined is a great way of starting to think through how we use and the possibilities for the BPSec protocol itself. I also know that there are security contexts being talked about as being standardized in CCSDS. With my chair hat on, my question is, has anyone in the COSI environment reviewed this document? And could we, between now and the next IETF, if they haven't been able to review it, could we get a quick review of it? Maybe, as Rick suggested, after a minor edit to resurrect the document, so that going into 115, we know that we've gotten that extra review.
Sure.
Ed,
I had.
Sorry, Brian. Ed, I'm going to just, I think before we can reach out to the COSE group, I think it's probably worth us adopting it first, because it seems a bit odd to ask the COSE guys to have a look at something that's an individual draft. I think it will be a lower priority for them. But I think we can move fast on this, and I think it's valid to get early review on this.
So I completely agree, and I personally, I'm happy with adopting this document as a working group document.
Okay. In the past, I had brought it up, I believe, on the COSE mailing list, and like Rick had said, just as an individual draft, it wasn't very much of a focus for anybody on that list.
Cool. Let's move on, Brian. So
Okay. So those two topics were more focused and more concrete, requesting of adoption. This next topic is more speculative and more asking for comments, and it's a bit of a broader topic. So the general topic is in neighbor messaging, and more specifically neighbor discovery, in support of one of the working group charter items. And the current charter has neighbor peer discovery as a milestone. There's an existing experimental draft from the IETF called IPND that does its job in a narrow scope, and it lacks some things that a full-on standards track protocol would have, like extensibility and security. And what this proposal is pulling together is to be able to say, we want to not have to reinvent extensibility, not have to reinvent security, and reinvent some of these things. So the idea is that we want to make use of what's already present in the BPA and BPSec. So the idea here is that BPSec already provides a way of doing message authentication, and potentially in the future signing. And BP already provides things like lifetime limitation, hop limitation, and convergence layers already provide things like unicast transfer or multicast transfer. And so the idea of this is saying that there is this new thing called a neighbor message, and it is a bundle with a specific bundle destination, and it has a certain amount of security that has to be applied, but it's not proposing new mechanisms, just mandating uses of existing mechanisms. So I'm going to skip through a little bit of content just for the sake of getting to some feedback, if there is any. But the idea here is that a neighbor is a one-hop destination. It's some peer that's directly reachable through a convergence layer. And what is being proposed here is a new well-known endpoint in the same way that DTN none is a well-known endpoint to mean anonymous or the lack of an endpoint. This proposes DTN neighbor as a non-specific destination. And that would mean that the BPA knows how to handle this endpoint and knows how to process it in ways that need to be done to do neighbor messaging. And then the idea is that the contents of the payload are a map with some labels defined similar to existing protocols that use CBOR, and it also falls in line with the way MANET uses its own packet and messaging format. And this would say, use these existing bundle lifetime previous node hop count blocks to control processing. Don't invent any new extension blocks here. And the idea is that it would be doing the same, as a starting point, it would be doing the same kind of job as IPND, but it would take advantage of these new capabilities that have come since IPND.
Go ahead, Ronald. So we're blessed to have a MANET working group chair here to offer some feedback.
Hello, Ron Linveld. Yes, I'm a manager, but this is a more heads-off comment. So if I understand you correctly, then you have to use always, there always has to be a UDP-CL present to do this.
So depending on the use case, yes. And what that means is that it's described a little bit in some of these comments. Let me see if I can find it here. There is a slide that talks about the convergence layers, but in a open network where you don't know anything about what's happening, you would need to use something like multicast UDP messaging to be able to send a message. But if you're operating in a more controlled environment, say where you have specific links that are advertised by something like DLEP, then what you can then do is you can say, well, when a link comes up, probe that specific peer. And it would be a network configuration to be able to set things up in a way that you administratively know what kind of convergence layers are going to be present on the network. But in a general network, yes, you would need to use UDP multicast, but in a controlled network, it wouldn't necessarily be that way.
So it's not a universal solution, and there's still a place for something like IPND or something similar.
It could be. The idea is that the hello message would cover the same ground as IPND. That's the intent, is that it's IPND plus the ability to do integrity signing and some other aspects.
Okay. Thanks.
Go ahead, Scott.
I like this idea a lot. The convergence layer aspect of it, I think is still, it doesn't seem quite right in my mind. What I'm thinking is that these conveying these messages in bundles is cool because it would get the right information to the bundle protocol agent. I think it would be simpler and cleaner, maybe, to add in something additional here, which is essentially a discovery convergence layer adapter that has any number of different underlying link service adapters of its own, so that bundle protocol doesn't have to like deal with a million different things in order to handle these things. And I'm thinking here of LTP as a model. We run LTP over UDP. We can run it over space protocols. and all of that complexity is bundle protocol is shielded from all of that stuff by the standard LTP protocol functionality. I think if we had a neighbor discovery convergence layer adapter that that shielded BP from the details of how something is going to talk to it, then BP could stay simpler. The convergence layer structure for the network could be simpler, and the link service adapters underneath this neighbor discovery convergence layer protocol could be adapted to whatever the network that the subnetwork that the node lives in can sustain. So I would like to propose that we interpose a new neighbor discovery convergence layer protocol to convey these messages.
Thanks, Scott. My comment is, I'm afraid I'm going to disagree with you, Scott. I don't think this needs a new convergence layer, and I like this. I think what I think is the most elegant part of this, apart from, yeah, we need a standardized way of passing around the neighbor messages, and yes, Mane has done a lot of work in this area, and there's a wealth of experience we can look at there. The DTN : neighbor, I think that's very clever. So you can formulate a bundle and address it to, I need to address this to my one-hop neighbors, and then leave the internal implementation of the bundle processing agent to say, I know how to resolve that name to whatever convergence layers I'm running, and whatever those convergence layers understand by how to get things to a one-hop neighbor. I'm running DLEP on a couple of these physical interfaces, and I know I'm going to run I've been pre-configured to run a certain CLA on top of that. So I can use that signaling to say, oh, now I can transmit this bundle to my one-hop neighbor. And equally, you could have some kind of UDPCL which understands broadcast, and you can do that. Or you can have some non-broadcast multi-access overlay tunneled thing, or LDP or whatever. And yes, there would have to be a per CLA understanding, but that's part of the name resolution mechanisms to say, I've got a name called all my one-hop neighbors, and I know how to resolve that to get it to all my one-hop neighbors. So I'm kind of turning this into a naming and addressing topic. I think,
and that is why I
CL
brought this up originally under the
Yeah.
naming and addressing.
Go ahead, Eric.
Yeah, Eric Klein, Illyria. Forgive my ignorance on a bunch of this stuff, but I was thinking along the lines of kind of what you were saying, Rick. I think that there would be no problem to just like request a link local multicast address that represents all DTN nodes, and then you can put it in a UDP message to that. If you have unicast destinations that like you already have a convergence layer attached, then you can send the message as if it were unicast. And if you want to do a multicast, just ask for a multicast link local prefix for V4 and V6, and away you go.
And the intent of this is also that a smart BPA is going to be able to do a lot of complicated things, but a dumb BPA can just follow some interoperability profile and do very simple things.
Thanks, Brian. Have you got anything more?
I have some other slides that I can skip over for the sake of the details, but there is a separation between, I'll just mention the separation between this hello message content, which mimics the kind of content of a hello NHDP kind of Mane message that just says, here's who I am, here's my identities, here's some cryptographic binding of those identities, here are the CLs that I'm actively using, here are the CLs I'm listening on. Here, like the idea is that this is more extensible content, and there can be again an interoperability minimum for this thing, but the idea is that definitely it's a place to put vendor and specialized extensions to expose whatever needs to be exposed for doing handshaking.
Go ahead, Ed.
And I just wanted to call attention to a comment that Ronald had put into the chat, which is that NHDP is about 2-hop neighbors, And I wanted just to clarify that Brian, what we're talking about here are one-hop neighbors, your immediate neighbors, and that we're not trying to establish a two-hop neighborhood in a DTN, which may be a difficult thing to do.
Yes, yeah.
So Brian,
That's correct.
second question, sort of prompted by Eric slightly, is have you got this as an individual draft in any form? Are you in the process of writing this up?
No, so it exists. There's a link at the last page. This link exists as a standalone, not a data tracker document. It has missing sections. It's not complete. This was put together as a kind of a touchstone of, is this worthwhile, without spending too much time on the details that have to be present for it to be a full document. But
So
if there's enough interest, then yeah.
So my question is, this is on charter at the moment. Are you looking for collaborators to, because I noticed this would be your third ID you would be committing to get ready. I'm looking at people like Ronald, who has previously expressed a real interest in neighbor discovery, but I know this has had some discussion amongst today, and I know people have talked about this before. Would you like some collaborators to help make this move forwards?
Yes, definitely.
Okay. Sorry to push on time, but go ahead, Ronald. You're in the queue.
I would certainly be willing to review whatever you write. I cannot really commit to contributing a lot of text at the moment, but I will review.
Okay. And it really only exists as a concept right now. It's not been at all worked down to an actual detailed level. But if you are able to access the PDF from the data tracker, then this link will yield you a document to read.
Okay. Is that it, Brian? Are you happy with that?
Yes.
Perfect. Thank you very much. In which case, we'll move swiftly on to Scott, who I think is just going to kind of tee up the second hour of this session by going into naming and addressing, and hopefully that will set us up with some topics. Ed, I know you've got a sort of rough outline for some topics to discuss as part of the workshop, which I think we may naturally slide into off the back of Scott's presentation. But just to reassure you, we have a soft agenda for the second hour, but we'll start with Scott. Thanks, Brian.
Okay, shall I start?
Go ahead, and you have control of the slides as well, Scott.
Okay. Oh, how do I advance the slides?
If you float your mouse down to the bottom of where it shows on the screen, a little
I see.
semi-transparent bar
Okay.
will appear.
Okay, I'll try to go quickly because I know we're running short on time. What I will assert here is a couple of definitions that people will undoubtedly take issue with later on. I'm going to assert that a name is a character string that identifies a thing of some sort, distinguishing it from other things of the same type. So you have a type, you have scientists. Well, the names that distinguish different scientists might be, for example, Max Planck, Marie Curie. The names of things that are of type movie, you might have, for example, Citizen Kane, The Godfather. Location is a type of thing. It's a different thing from state machine. It is a point in some sort of space. So, for example, the Pyramid of Khufu resides at some point in the space defined by the latitude and longitude on the surface of Earth. The state machine that is driving this particular display it resides in a space that is the internet, which is located by its connectivity to other state machines. That's the topology of the network. An address is the name of a location. A node is a state machine that resides at some location in a network nodes, names of nodes and names of locations are both names, and they're typically associated because a node typically resides at some location in a network. The name of the location needs to be unique within the network in order to associate it with a node. The node has a name, and that name also needs to be unique among nodes in order for messages to be directed to that node and rather than to some other node. Among the properties of a node are the node's name and its address, which is the name of its location. And at any moment, there's an association between the name of a node and the address of the node, which is the name of the node's location. If the node's location never changes, then you can sort of take a shortcut and you can use the address as the name. For example, if you send a letter to the White House, it'll go to the President of the United States. You don't have to say this is to the President, it's the location is enough. If the location does change, then the association between the name of the node and the name of the location of the node has to be recorded somewhere, and you have to revise it when the location changes. In order for data to be sent through a network, which is actually what we were saying there, is it's copied from one node in the network to another node in the network. The data has to first arrive at the location at which the destination node resides, and then be delivered to the node at that location. And we do that by forwarding the message along a route, which is a continuous succession of connections between neighbors, which are nodes whose locations are topologically adjacent. Their locations are connected. That's what being a neighbor is, really. In the internet, the IP network locations of nodes don't change often, and the propagation of information about those changes is really rapid. So the source node, if a source node is sending data to some destination node, its knowledge of the destination node's address can be used to direct the forwarding of the packets that are destined for that node, because the source node's knowledge of the address of the destination node is likely to be correct. The location of the destination node changes infrequently, and if it does change, you find out about it pretty much right away. So the number of packets that are forwarded on this basis along obsolete routes is not significant. You don't have to worry about it happening in the internet. In DTN, that's different. In DTN, the BP locations of nodes may change often, and in particular, the propagation of information about those changes may be really slow. So the source node's current knowledge of the address of the destination node is less safely used to direct the forwarding bundles destined for the node. The forwarding may take so long that the node has changed location before the packets can be delivered. This is where we get the idea of late binding. The problem here is that information about a change in a destination node's location may be getting propagated through the network, but hasn't made it all the way to the source node. It may be only part way along the path to the source node. Some other node may have the most current information. And so for this reason, what we do in DTN forwarding and when we're forwarding a bundle is we use the destination node's name to look up its address, because it could be different from what the source node might have thought it was. So this is late binding. So for this reason, the destination that we encode into a bundle really needs to indicate the destination node's name rather than its address. The name is always going to be reliable. It's going to be, the node's not going to change its name. That's its identity. The destination, the address of the destination node may not be reliable at the time the bundle is sent. We can imagine mitigating this constraint a little bit by saying, suppose you've got like large areas of the network topology that nodes may move around within, but they don't usually change from one region to another. So for example, similar to, I live in Los Angeles, I might move to San Diego, but that's all California, or it's all United States. So if you address, if you add, for example, the name of this large region like UK to the destination of something, well, that part of the resolved location of a node is unlikely to change very much. And if it does change, you may find out about it, soon enough to be able to correct for that. So that would limit the scope of the location lookout, the late binding function, to be within that broad region, and that could simplify some things. So in that context, supposing we have that kind of mechanism, how do you get it to the edge of the destination node's region? How do you get it across the region boundaries until it gets to the region within which the destination node resides somewhere? And the region concept that we've been working with in ION recently is, suppose that you have got multiple regions. Each region has a name. Each region has a location, same as a node has a location. The location of the region is within a tree of regions, and you can think of it as a network of regions. And there are passageway nodes that connect the nodes of one region to the nodes of adjacent and those neighboring regions, and these are nodes that are located. They have locations within both of the two neighboring regions. So a bundle in that case can reach the destination node's region by being forwarded from one passageway to another through the tree. So how do you know which passageway to forward bundle to in order to get it to its destination? Yeah, Rick?
Scott, can I ask a clarifying question here? So
Sure.
I completely understand, well, I think I completely understand what you're discussing here, and there are two ways to view it, and I'm interested to see which way you're looking at it. One is to say, this is effectively subnetting. So I'm saying, although there is mobility amongst the nodes within a certain space within my topology, it's reasonably localized, so I can make a rough decision to say it's going to be down that side of the tree, headed over into that region, and you'll find it over there. So the later lookups will with more accuracy find it. So
okay.
That's what I would call subnetting. The other question is, if you look at it from an addressing perspective, are these regions individually, as a naming perspective, do these regions have different naming schemes, and are those names handed out by different authorities that have a loose agreement between them at these passageways? So one's
can we come back to that question in a little bit?
Okay, fine.
Right, because I think it's something I want to dig into a little bit more so that I understand it better. Because I don't see an issue, but there may very well be one.
Do you want to take more questions, or I've interrupted because we got Mark?
No, I can take. Yeah, sure, Mark.
Hey, Scott, can you hear me?
Yes.
Okay, so can you go back a couple of slides? I just have a quick question about something that you said about the regions.
Yeah. How far back?
I think one more. Maybe one more. anyways, I don't know where it was, but my question is this. So if at some point in one of the slides you seem to imply that within a region nodes don't change much. So if that is the case,
what I thought I said was that within a region, the location of a node might change a lot, but it might not change from one region to another region very often.
oh, I see. So late binding is needed within a region because you do assume that it moves, the location of the node moves within the region.
Yes.
Okay, that was it. Thank you.
Oh, okay. Let me pick up where, okay. All right. So, so if you have this, and I think at the moment I'm working with something that is that RIP is identifying as a subnetting notion of regions. So one way to make that work is to have management of the region tree, have a global authority that manages the region tree, and announce the region tree topology to every new node when the new node is instantiated, and communicate changes in the region tree topology to all the nodes in the network, so that every network knows the topology of the region tree. There is the downside to this is that there is a tree management and synchronization challenge there, which is subject to the usual kinds of political problems, and is exacerbated by the latencies and propagation. But it's a familiar sort of thing. So we do something like that in the internet. It's just slower.
Scott?
Oh,
sorry, I just wanted to call attention. We do have another question in the queue, so I wanted to not get too far ahead.
Oh, yeah, sure.
So yeah. John, go ahead.
Hi, Scott. Can you hear me?
Not very well. Let me turn up my volume a little bit.
Okay, not sure which mic I'm using here. I got a couple of them, but my question is, do you anticipate regions to be predefined, or are they dynamic? So
dynamic.
And as a region, okay, and a region is a going to be predefined by a location.
The notion that we've been working with is, because it's based on contact graph routing, but it's extensible to other kinds of routing approaches. But in the contact graph routing context, a region would be coterminous with an identical, in one-for-one with a single contact plan. So as you define a contact plan, that defines the region. Regions are strictly topological, they're not geographical at all.
Okay, so technically, if a node, let's say that I was flying the space shuttle to Mars, on my way out, I might be part of one region. When I get out there, I might become my own region, and then
ideally you might not be moving into a different region until you got to your final destination, right? That is, the region could extend all the way from here to Jupiter. The region is not geographical; it's topological. The region is the set of nodes that that communicate among themselves according to the contact plan.
Okay, so at some point I could be in a region and then I guess leave that region, and that region may not even exist if there's a single node on that region.
Sure.
Okay. Thank you.
Yeah. Okay, so picking up on this idea here, this managed region tree, what you end up with is a globally managed structure that you can use to compute a path through the tree if you know the region that your destination node is in. And each node forwards the bundle to the passageway that it will get it to the next region on the path of passageways. A second option, which is the one that there's been some research on, and that attempts to avoid the global management of the structure, is to base it all on a discovery protocol. The topology of the region tree is locally discovered and revised by pairwise agreements between region management authorities. So the complete topology of the tree never needs to be recorded anywhere, which is advantageous, especially if you have like a large number of regions. Yeah, Rick?
Okay, it's slightly with my chair hat on. We're in danger of slipping into routing here. So, and I know we have to be quite careful to dance around the edge of it, but I'm very happy for us to talk about how does a bundle processing agent work out which of many next hops it wishes to push a bundle out to. I think that's entirely in scope, and that depends on having names and addresses and some kind of concept of topology. That's fine. When we start to say, actually, the way we name an address implicitly gives routing information, I think that becomes an increasingly contentious subject. And I'll give you my reasoning. For the same, you, Scott, introduced, along with your collaborators, the late binding concept into DTN, and it's one of the fundamentals of it, which is you can make an accurate decision after the bundle has entered the network in order to get it somewhere. Mm-hmm. If the name you assert to the destination has already enforced how that bundle will get there, then I think you've just broken the point of late binding. It's well, and you're adding a pre you're pre-enforcing how it must get there because of the way you have structured your names, and I think that's right to the way we consider the DTN problem space. So I'm very wary of going in this direction, and now I'm speaking personally about this. There's something about this that doesn't quite chime with me. Sorry.
Well, which is why my next, where I'm going to next, I think addresses that. Or at least I think it does. Which is that this discovery mechanism where the topology of the region tree is adjusted locally by the management authorities for the regions. You don't have a complete tree topology, and so you don't route on the tree topology, you don't compute paths through the tree topology, and you don't violate the late binding idea. That is, this is late binding taken very seriously all the way to the bottom. I actually prefer this, and this is the thing that's implemented in there's a feature branch of ION that has got this built. I think it's a better way to go, but it is it's a less familiar model, as I'll get to in a second, and on that basis, it may be that people are more comfortable with a sort of a hybrid approach where you can compute a route through a known topology of regions, and then you do late binding discovery within the region. I'm not going to say I like that better. I think it's in fairness to people who have proposed this. I wanted to identify it, and that's really what I was doing just a moment ago.
So Scott, sorry, Rick yeah. Again.
Yeah.
I understand the difference between having dynamic discovery of the path through the network, the path through your tree, and having it pre-placed, and that's a valid point. But I still, to me, I think you're describing the name of something as go here, then here, then here, and you'll get it there.
And I really am not. And I need to get to the end of these
I'll
to
shut
say
up.
how I'm not doing that. So the advantage here of going with this automatically evolving tree is that when you encode the destination, if it's a globally managed region tree, you need to include in the destination the name of the region that the node resides in, so that you can do this computation. If it's an automatically evolving region tree, then you don't. The destination is only encoded as the name, and you're late binding all the way. These would be, in my mind, two different endpoint ID definition schemes. They would affect what you need to do when a node moves from one region to another. In the globally managed tree option, you need to change the destination encoding for that node at every node that sources bundles destined for that node. So it's I think that's undesirable, but it again lines up with a more familiar model. If you have an automatically evolving region tree, the destination encoding doesn't change because all it is the name of the node. But in that case, you have to like rediscover the new passageway sequence by doing some other mechanism that I won't go into here, but it's basically a sort of a probe through the network to discover the right sequence of passageways. In both cases, you would want to provide advanced notice of the date and time of the change so that everybody can get the information ahead of time and be delay tolerant and not be affected by signal propagation delays. This would give you time either for to schedule either the changes in destination encoding at all the nodes, or else the issuance of new probe bundles. And summing up, I think this globally managed region tree is a familiar model. It imposes modest additional overhead. There's some additional administrative complexity. Not my favorite, but it's, you know, in fairness, we should consider this. I prefer the automatically evolving region tree, late binding all the way down. No additional overhead in data traffic, but during path discovery, of course, you have to get the information discovered in all the appropriate places somehow, and so there needs to be some discovery protocol activity to make that happen. I think that can be, depending on how the regions are managed, I think that can be modest, but that's a fair topic for discussion. And that's the end of my slides.
Thank you, Scott. I'm going to come back with a personal comment again. I think the summary slide's really useful. I think the second bullet describes my personal understanding of what we're trying to do in terms of forwarding and routing in complex networks. So that this is kind of how we've built the internet. Okay, let's not get caught up in locator ID separation, etc. But fundamentally, the paths across the network change over time. We have protocols which update what those next hops actions that should be taken by the routers within the network. So that allows you to have that evolving. And you could view a topology as a tree, but it's probably a more complex, hopefully acyclic graph. Your first point could be a very interesting short-term compromise, and it's more of an open question to the working group, or whether that would be something an organization like CCSDS would be interested in, where there would be a new node EID scheme which encapsulates within the name the exact pre-known path of how to get to somewhere. So it would be rick.bristol.uk.earth. You know how to get to me now, or backwards. And I'm not saying that like a DNS name. There's no looking up. It's implicitly known how to get there, and it is encoded in the name. Now, my personal opinion, as I said before, is I think that goes against what we're trying to do with DTN, but I can see that appealing particularly to the space community for a specific project, for a specific mission or whatever. They know everything in great detail, or I hope they do. So it might be entirely viable for them to do that. However, from an IETF perspective, I don't think that's a use case that's valid to the working group, and I wonder whether any working group members are interested even in working in that, or whether actually we ought to be tackling that harder problem, which ties into the late binding concepts, which are so strong, and managing big complex systems that are fairly future-proof.
Two things before we take the questions. I agree with you. I think the second is the second option is superior and is more DTN like. The difference in the way you encode the destination, whether you include the name of the region in the destination encoding in the bundle, is why I think this question belongs in the discussion of naming and addressing. You have to drag in some routing ideas to make the point, but it is a naming and addressing question. Do we stick with the idea of naming the node and addressing a bundle to a node by name, or do we stretch things a little bit and include a gross location of the node, the destination node, in the destination encoding, the name of the region that the node is in. I prefer certainly the automatic evolving region tree and just using the destination node's name as the destination in the bundle, but it's a reasonable thing to talk about. And I think it's Ed's up.
So Scott, just to agree, I think that this does resolve into naming and addressing. The question that I have, and maybe after Eric comes after me, we can get into this as the discussion is, how does this imply format, structure, restrictions on the names? And my comment is, instead of saying that if we were to presuppose that destinations, as you have talked about them, have sort of a region and some additional information related to that region, do we consider that entire destination to be either late binding or not late binding? Or within the structure of a destination, do you say if you have a region ID, the region ID is not a late binding concept? And the internal to the region piece, that may be late bound, and because we've structured the destination itself, do we treat different pieces of that destination differently from a binding perspective? Is that what we would need to do to make something like this work?
For me, the key question is whether or not there's any topological information of any kind in the encoding of the destination. If there's topological information in there, for example, the name of the region that the node resides in, then you've got you end up with the globally managed region tree kind of thing. I mean, you might be able to do it automatically, but there's no advantage, I think. You need to do things like when the node changes regions, you need to tell everybody in the network that the node is in a different place, and the encoding of destinations needs to change. If you omit all topological information from the destination, which is to say the name of the node, the unique identifying name of the node, and nothing else, then you avoid all that. There is a cost to that, which is that then you need an automatic mechanism for discovering the paths through the region network. And I will say tree because I am convinced that a tree is a much better way to do it. But if you can accomplish that automatic management, pairwise management of the connections in the tree, then I think that approach is is superior. There's less thrashing in the network. As soon as you admit of any topological information at all in the coding of the destination, you are no longer doing complete late binding. You have bound, right? You have early bound to a limited extent. You have early bound the destination of the node you're sending to. Does that answer your question?
I do want to jump as quickly as we can into in the time remaining to at least lay out some of the topics. My point is exactly what you're saying, is that if we go this route, there is that would be the requirement to have that early binding concept, at least for something like regions and the topology. But let's go over to Eric.
Sure.
Eric Klein, in the interest of time, I'll try to keep myself to clarifying questions. Does a node know all of its available names as it moves from region to region, or does it never change names? I'm having a hard time with this abstract stuff. I'm trying to build
in this concept, I would say that a node only has one name, and it always has one name, and that's all. Well, no, let me say that again. It might have IDs. It might have node IDs expressed in multiple endpoint ID schemes for other reasons, for implementation reasons. But its name within any single EID scheme should never change. If it does, it's a different node at that point.
So there might be a DTN colon name and a DTN-region colon name?
DTN-region.
I'm trying to understand.
When you say DTN-region, do you mean region literally, or do you mean DTN-XYZ region, DTN-WQR region?
Perhaps either. I'm trying to build some sort of a sample thing to like grab my head around, because all of this is pretty abstract.
Yeah, that would be an interesting way to do it. You could say, I'm sending this node to node ABC, and I'm sending it to its identity within region so and so. Whenever it's in region so and so, it's available. It's possible for it to be delivered there. And if it's not in region so and so, then when I send it there, it's not going to get there. I would need to think about whether there's an advantage in doing that. My instinct is that I don't see it as being advantageous, but that I should think about it.
I'm just trying to understand some more. Thank you. I'll save the rest.
Go ahead, Jordan.
Hi, Lee.
I was just going to make the comment that the automatically evolving region tree cost is, when you send out these probes, it's going to take a while to determine what the optimum the tree topology looks like in the subtrees and so forth. And in interplanetary networking situations, that may be totally intractable. If it takes 40 minutes one-way light time to get to Mars and 40 minutes back to find out which relay node you need to talk to get to a local Mars region, by the time you formulate your plan to go ahead and use that probe to send to that particular passageway, that particular probe, the orbiter might be on the backside of Mars, and you've completely missed your opportunity. So we need to be careful about thinking through the delay part of delay tolerant networking. And that's my comment.
Yeah, I completely agree. I think the way that this thing would have to work is that things like which side of a planet you're on and so on would not be region scale considerations. Those would be considerations for late binding within the region. That a region would be something that a node would not casually or frequently change. That is, you don't casually or frequently move from the United States to Portugal. If you did it, it would be a big deal, and there's definitely an overhead in making that happen, and that overhead is incurred rarely enough that you can tolerate some suboptimal network performance while it's going on. That's the idea.
So, Jordan, I would consider that topic to absolutely be routing and therefore slightly out of scope for this. But yeah, everything you've highlighted are absolutely good considerations for how do we manage and maintain the forwarding information in the individual bundle processing nodes in an optimal and usable way. Scott, you and I have talked about this region concept before several times, and I think where
Yes.
you and I have disagreed is I love the approach, but I would like actually regions not to be topologically significant. And by that I mean talk about how you get a bundle to a direct to an end destination, but actually to be a way of subdividing the naming space so that you don't have to have the phone book of everyone in order to map a name to who the next a name to route to the destination. So I'll give you a worked example. Let's say you've got a region called ESA and a region called NASA. Then both ESA and NASA can have a Mars rover called Mars Rover 2.
Oh, okay, sure.
If I am part of the NASA team who wishes to send some sort of information to the ESA Mars Rover 2, I set the destination of the bundle to Mars Rover 2.ESA, for example, and I don't really care about the encoding. So within the NASA space, within the NASA network, the individual nodes that are moving that bundle around may not know where on earth Mars Rover 2.ESA is, or where on Mars Rover 2.
There we go. Thank you much. Have a good week.
But they, well, hey, but they do know how to get something to someone who is in the ESA naming region. So they can get to your passageway, what I'd call a gateway traditionally, to say, oh, if I get it to this node, that node will be able to resolve that ESA name to something. It might be the ESA NASA gateway, and there might be a peering agreement between ESA and NASA to say, here are some gateways that have a name in both. So you could have ESA NASA gateway.ESA and ESA NASA gateway.NASA, both names assigned to a single BPA because they understand both areas. And these could be pretty fat nodes, place them in a sensible place in your network. So I'm not talking, I love your concept of regions, but I would like to divide the naming space and not the routing space into regions, because I think it's just requiring a top-down name registrar for all names of everything everywhere. And I think it gives us a lot more flexibility in terms of peering agreements and about how we build these larger interconnections between these various naming autonomously named regions.
I think hierarchical naming structure is perfectly reasonable, and in fact, my preference is not to use ASCII names at all, but rather to use node numbers, and for those node numbers to be assigned in uniquely identifying, but to be assigned within ranges that are associated with organizational entities, so that the organizational entity could be inferred directly from the destination node number. And then if you have a routing system that can use that hint to improve your routing, then by gosh, go ahead and do it. I think for I think the notion of region as it's used for routing is separately important, because you wouldn't necessarily have to base your routing decisions on knowledge of peering agreements between organizational entities that own the nodes. I see nothing wrong with enabling that kind of mechanism, but I think it's more general if we don't require it, and that's why I think the region structure is a topological structure rather than a naming mechanism. I think the naming mechanism ought to be in the names themselves. But I don't want to like dominate the conversation with that. I think Stuart has maybe other ideas, but you've got a response to this.
Right, my response is, let's take this offline. I think this is a really interesting conversation to have.
I agree, yeah.
Go ahead, Stuart.
Stu Card here. So a comment, request, and a question. First, the comment. Thanks, Scott, for a very logical shaping of the discussion. Your first few slides, I think, bring a lot of clarity to this. Then the request. I hope that as we go forward, we can not paint ourselves into a corner that precludes essentially an ARP function that maps us into different identifier spaces, different logical location spaces, and different physical location spaces. Two with which I'm particularly concerned are host identity protocol, host identity tags, especially the new hierarchical host identity tags, and high frequency automatic link establishment addresses, ALE addresses. And then finally the question, do your regions partition a space or can they overlap?
Good question. And I would say the regions partition the topology at the same time. A node can be a member of multiple regions. Every passageway has to be a member of multiple regions. If you could take that concept of passageway, that is membership in multiple regions, which is what would enable overlapping if you wanted that. You could take that to an extreme and say any node can be any member of any number of regions, and therefore you can route in some interesting and optimized ways. I think that's a direction to be avoided, because and there again, this is going to my firmly held conviction that the regions ought to be organized in a tree. It is from an implementation point of view, I think very difficult to avoid introducing routing loops if you have the regions organized in any structure other than a tree. In order to avoid routing loops, I think you need way more information about the region topology, and that gets you back to all the same problems of globally managing the region tree that I think it's desirable to avoid. If it's automatic, then the tree automatically forms itself if you limit the rules by which things connect up. If it's not a tree, then I foresee potentially very major headaches in getting the topology to work in a reliable way.
So I close the queue. Thank you very much, Scott, for that answer. Zahed, go for it. We have about 6 minutes left. So
Yeah. Yeah, Jahed, your transport lady, and I'm actually putting my heady hat on. Yeah, I mean, we started the discussion about Rick, you saying like we don't have a document, but we don't want to commit to that. We're not in at that point to commit to write documents, but thanks to Scott and to the working group, I mean, this was a really good discussion. And I think there is a certain maturity of the ideas and certain pros and cons that I think now it's time to actually write it down, because I see there are a couple questions like how the name could be, how the schemes could be, how the regions could be. I think it's very good to have the discussion when things are documented. So this is not only the presentation. I look or the recordings I'll have a document, and actually I can read and see like what could make more sense, right? So I strongly recommend the working to come. So somebody, maybe Scott, yes, to actually write it down, and then we can have further discussion on that one. So that's my idea on, and then my understanding of the reason and concept of like overlapping question that Stu asked, like if you can have overlapping reason, but then the problem is you cannot have a name collision. You have to avoid that, and that's the complexity it will bring in if you overlap. So yeah. So my advice to the working group: please write things down so that we have a more constructive discussion going forward. And this is a very good discussion. We have 3 IDs here, so you're well covered.
It has taken us, I think, this long to get to the point of being able to articulate these ideas at this level, at this puny level. So I agree. I think if we're interested in pursuing this direction, then I think it's a good time to start on a draft, and I would be happy to participate in writing that draft.
I think that's a great starting point. I take Zahed's point about let's have some text which gives us the kernel around which, the grain of sand around which we can build a pearl. It might take us a while to get there, but it means we have something to point to. Because I was looking back through the history, we had an interim on naming and addressing in May 2021, where a lot of these things were introduced, but we have many slide decks talking around this. But I think Zahed makes a very good point about let's just try and get some text there, and then we can have vigorous and practical discussion on the mailing list to really hone it down to something.
I certainly agree.
Brilliant. Thank you, Scott. And that doesn't necessarily mean, Scott, you have to do it. It means if somebody is feeling bold, go for it. Collate what's out there, or put your own ideas and put it in text. And there is no problem with having 3 documents that take different approaches. That's great. We can proceed in that way. We have 3 minutes left. We always try and give 5 minutes at the end of the session so that people could bring up any other business. Hint to Ed, there was the compressed bundle header registry, IANA. I'm not sure if you wanted to mention that, or if anyone has any other general topics, this is your chance to jump to the queue.
All right, so while we're waiting, I'll unlock the queue. So while we're waiting for people to jump into the queue, 2 things real quick. One, observation that we seem to have no problem filling in 2 hours, and more sessions hopefully will be available to us at 1:15. The second is question: should we try and have an interim meeting before 1:15 to try and pick up on some of the naming and addressing workshop that we weren't able to get to today? To, I think, Eric's point earlier, there is a real question as to how are nodes, how are EIDs used? Not just used from a routing perspective, how are they used from a security perspective? How are they used from a custody perspective? How are they used when we define contact plans or things of that nature? Very concerned about the idea that a bundle may be identified using one DTN scheme, and then at a waypoint node or at a destination, security policy or other policy may be using a different EID scheme. and what happens in those cases. I think that this is going to push us to creating some kind of structure to our EID scheme names, but perhaps not. And I think we need to understand how do we exist with multiple names for the same nodes, multiple names for the same EIDs, and what is that practical cascade into security, routing, custody reliability, quality of service, and other things. And I think until we really get a handle on that, we should not be going too deep into the users of DTN names until we get the naming itself done. So I would recommend that we have an interim meeting between now and 1:15.
Thanks, Ed. I 100% agree with you. And as co-chairs, let's just get that arranged. And if publicize it on the list, and if nobody turns up, that's fine. We can just shut the queue. So I think fully support that. Go ahead, Scott. Keep it short because we're overrunning, and they're going to turn our mic off fairly soon.
Right. Very briefly, I think this would, of course, be very controversial. I think we should settle on one EID scheme. It should be no numbers. And I think that the resolution of names to numbers should be a local implementation matter supported by the capabilities provided by the networks within which the nodes are located. And I see glee. I will desist.
It's glee because I think you should put that on the mailing list because it's been quiet. I think an enormous amount of feedback will come off the back of it. We will all be positive, but I think it will be vigorous discussion around that subject. And I look forward to seeing the mailing list light up with debate on that subject. Meanwhile, thank you very much, everyone, for your attendance in strange time zones and in person. It's been great to meet some of you after 2.5 years in person again. And I look forward to seeing you at our interim and also in London, and speak to you on the mailing list as well. Thank you very much for your attendance. And I'm closing the meeting in some way. Meeting adjourned. Yeah. Meeting adjourned. There was no end.